Section 5.4 Orbital Diagrams and Electron Configurations. We can now look how electrons are arranged in the orbitals within an atom. An orbital diagram shows the placement of electrons in the orbitals of order of increasing energy level. In the energy diagram, we see the electrons in the 1s orbital have the lowest energy level. The energy level is higher for the 2s orbital and even higher for the 2p orbitals. So 1s is the lowest energy level, followed by the 2s. Then the higher increasing energy is 2p, followed by 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. We can begin our discussion of electron configuration by using orbital diagrams in which boxes represents the orbitals. Any orbital can have a maximum of 2 electrons. To draw an orbital diagram, the lowest energy level is filled first. For example, we can draw the orbital diagram for carbon. The atomic number of carbon is 6, which means that a carbon has 6 electrons. The first 2 electrons go in the 1s orbital. The next 2 electrons go in the 2s orbital. In the orbital diagram, the 2 electrons in the 1s and 2s are shown with opposite spins. The first arrow is up and the second is down. The last 2 electrons in carbon begin to fill the 2p sublevel, which has the next lowest energy. However, there are 3 2p orbitals in the equal energy. Because the negatively charged electrons repel each other, they are placed in separate 2p orbitals. With few exceptions, which will be noted later in the chapter, lower energy levels are filled first, and then the building of electrons continues up to the next lowest energy level that is available until all the electrons are placed. Electron configurations. Chemists use a notation called electron configuration to indicate the placement of electrons of an atom in an order of increasing energy. The electron configuration is written with the lowest energy level first, followed by the next lowest energy level. The number of electrons in each sublevel is shown as a superscript. Electron configuration of carbon. Type of orbital S, number of electrons 2. So carbon reads 1s2, 2s2, 2p2. Period 1. Hydrogen and helium. We will draw orbital diagrams to write electron configurations for the elements hydrogen and helium in period 1. The 1s orbital, which is the 1s sublevel, is written first because it is the lowest energy. Hydrogen has 1 electron in 1s sublevel, helium has 2. In the orbital diagram, the electron for helium is shown as arrows pointing in opposite directions. Period 2. Lithium to neon. Period 2 begins with lithium, which has 3 electrons. The first 2 electrons fill the 1s orbital, while the third electron goes into the 2s orbital, and the sublevel with the next lowest energy. In beryllium, another electron is added to complete the 2s orbital. The next 6 electrons are used to fill the 2p orbitals. The electrons are added one at a time from boron to nitrogen, which gives the 3 half-filled 2p orbitals. Because orbitals in the same sublevel are equal in energy, there is less repulsion when electrons are placed in separate orbitals. From oxygen to neon, the remaining 3 electrons are paired by using opposite spins to complete the 2p sublevel. In writing the electron configurations for the elements in period 2, begin with the 1s orbital followed by the 2s and then the 2p orbitals. An electron configuration can also be written as an abbreviated configuration. The electron configuration of the preceding noble gas is replaced by writing its element symbol inside square brackets. For example, electron configurations for lithium, 1s2, 2s1, can be abbreviated as helium 2s1, where helium replaces 1s2. So neon, for example, is 1s2, 2s2, 2p6, which is the same as helium plus 2s2, 2p6. Period 3. Sodium to argon. In period 3, electrons enter orbitals of the 3s and 3p sublevels, but not the 3d sublevel. We notice that the elements sodium to argon, which are directly below the elements lithium and neon in period 2, have similar pattern of filling their s and p orbitals. In sodium and magnesium, 1 and 2 electrons go into the 3 orbital, and electrons for aluminum, silicon, and phosphorus go into the separate 3p orbitals. The remaining electrons in sulfur, chlorine, and argon are paired up with opposite spins, with the electrons already in the 3p orbitals. For the abbreviated electron configuration of period 3, the symbol neon replaces 1s2, 2s2, 2p6. So argon would be 1s2, 2s2, 2p6, 3s2, 3p6. Otherwise, you can abbreviate it neon 3s2, 3p6.